In the following example, we will apply our knowledge of z-test for population means by solving for the first 3 steps of the hypothesis testing, which are state your research question, provide statistical hypothesis, and state your decision rule. I will now give you some time for you all to read the following example. Let's identify what information was given to us. The problem provides us with the population mean, which is equal to 500. It also gives us the standard deviation, which is equal to 100, the sample mean, which is equal to 550, and the sample size, which is 100. Remember, a z-test examines how far the observed mean lies from a hypothesized population mean. Now we can move on to step 1. State the research question. The research problem in this example would be, does the mean math SAT score from UCSD students differ from the national average of 500? Next, we will identify the statistical hypothesis, which are the null and alternative hypothesis, which we will know as H sub 0 and H sub 1 respectively. The null hypothesis would represent nothing special happening. In the case of our example, it would mean that the mean would be equal to the hypothesized population mean of 500. The alternative hypothesis would then be that the mean does not equal the hypothesized population mean. The alternative hypothesis will always state that something has happened. Now we can move on to step 3, specifying the decision rule. If we are testing at a 0.05 significance level, we would need to divide 0.05 by 2 so we could get 0.025 for each tail of the distribution. We would then have to go to the critical z-value table and look for 0.025 under column C. We then find the z-value is going to be equal to 1.96. What this value then allows us to do is reject the null if the calculated z-value you will get in step 4 is greater than 1.96 or less than negative 1.96. Rejecting the null means that the observed C qualifies as a rare outcome. You will state the decision rule as follows. Reject the null if z is greater than 1.96 or z is less than 1.96. To recap, we have stated the research question, stated the null and alternative hypothesis, and specified our decision rule. We can now move on to step 4 and calculate the z-score.